Second, kinematics of simple harmonic motion.
Third, simple pendulum. Vibration. When an object is disturbed from its equilibrium position, a restoring force acts on its restore it back to the equilibrium position. If the object overshoots the equilibrium position, oscillates to and fro, the object is said to be vibrating.
Simple harmonic motion. To model vibrations, we need to set up a simple model using approximations and simplifications. The simplest model to describe vibrations is called simple harmonic motion.
In addition of simple harmonic motion, it is defined as the motion that takes place when the acceleration A is always directed toward the proportional to displacement, a fixed point.
Displacement is the maximum extent of the vibration acceleration measured from the position of the equilibrium. Velocity amplitude is the maximum speed of the oscillating object. Acceleration amplitude is the maximum acceleration of the oscillating object.
Simple harmonic motion is any motion where a restoring force is applied that is proportional to the displacement and in the opposite direction of the displacement. Or in other words, the more you pull it in one way, the more it wants to return to be the middle. The classic example of this is the mass on a spring because the more the mass stretches, the more it feels a tug back towards the middle. A mass on a spring can be vertical, in which case gravity is involved, or horizontal on a smooth tabletop. The motion of a mass attached to a spring was described as an example of vibrating system. The mass on a spring motion was discussed in more detail as we sought to understand the mathematical properties of objects that are in periodic motion.
Kinematics of simple harmonic motion is the period motion of a particle which follows a sinusoidal oscillation about an equilibrium position, demonstrating a single resonant frequency. It is illustrated by motion of an object on a spring when subjected on an elastic restoring force.
This is a circular motion to study the kinematics of simple harmonic motion. An object is going to be moving around the circle with a certain around radius per second. Going around in a circle with a constant of velocity. The spring is stretched right now in its relaxed position called equilibrium position. Notice that whenever a circle is right here, the box is right there. And when the circle is right here, the box is right there. The shadow of the circle is the x-component of a circular motion. It oscillates back and forth and it is called simple harmonic motion.
Simple pendulum is one which can be considered to be a point mass suspended from a string or rod of negligible mass. It is a resonant system with a single resonant frequency.
An ideal of simple pendulum consists of a heavy point mass called bob tied to one end of a perfectly inextensive, flexible, and weightless string. In practice, we make it by tying a metallic spherical bob to a fine cotton stitching thread. Length of a simple pendulum. The distance between the point of a suspension of a pendulum and its center of gravity, which is the center of gravity of bob, is called the length of the simple pendulum. Time period of a simple pendulum. Time period is taken by the bob of a simple pendulum to make one complete oscillation. Finding the acceleration due to gravity. The time period of a simple pendulum depends on the length of the pendulum and the acceleration due to gravity, which is expressed by the relation